Okay, so sometimes you have a set of numbers like 1, 2, 3, 4, 5, 6, and then you multiply it by 2, it becomes this new set of numbers 2, 4, 6, 8. So what do you notice about it? It's like there were different unique numbers at the start, and they are still unique, and if you know what process they went through, which is multiplying by 2, you can tell from this sequence what the original sequence was, because the information is preserved. But what if you multiply by 0 instead? Then the sequence of all these different numbers, 1, 2, 3, 4, 5, 6, 7, just turns into all zeros. And even if you know that it's been multiplied by 0, you can't just go back and say what the original sequence was, because it could have been anything. It could have been 1, 7, 6, whatever, or 1, 2, or even negatives, whatever, because every number multiplied by 0 is 0, so it destroys information. We can see these kinds of things in our real world, but in our real world, information is basically completely preserved, because, for example, if you have some bars of different heights, like 1, 2, height 3, and then you squeeze them, no matter how hard you squeeze them, they will, if you squeeze them in proportion, then they will still, you can still tell what they originally were, because you can't squeeze things to the point where they all become 0, right? Or can you? So we cannot, no matter how big of a hydraulic press we synthesize, we can't crush the information out of anything, because everything is still there. And given that we know all of the information in the entire universe, where each atom is, how fast it's moving, and all that kind of stuff, we know what its past was. We know perfectly well. But that's only because all the things that have happened in a finite context. We can't crush things infinitely, we can't stretch things infinitely, but black holes do. If we have so many different unique types of stars and whatever, and then they all just go into a black hole and get infinitely squashed down to nothing, down to no volume, basically infinitely dense, and they just become all the same now, and you won't be able to tell what star it came from or anything, because it's just matter. And this is called the black hole information paradox. They call it a paradox because we think that the universe should preserve all information, right? Because I think we're thinking that that's how math works, right? Because a set of numbers. But that's not always the case in math, if you multiply by 0, for example. And indeed, that is not the case in real life either. If you squish something infinitely much, that the information will go away. Now, this is not to say that the information does go away. Maybe something else happens in the black hole. I don't know. But I'm just saying, even if information is lost, it's not much of a paradox. And indeed, this is also where the problem arises from dividing by 0. Some haters of dividing by 0 would say that if 1 divided by 0 is infinity, then 2 divided by 0 is also infinity. So 1 equals 2. Well, that's like saying since 1 times 0 is 0 and 2 times 0 is 0, then 1 equals 2. Well, obviously not. Just because you put 2 different numbers through a function, they become the same answer, doesn't mean they're actually the same number. All it means is that this function destroys information. It's not a unique one-to-one assigning function like multiplying by 2 or most other functions. So, one last thing. You know how I've just been saying that 1 divided by 0 is infinity, and I never really told you what I meant by that. So, there is an argument that 1 divided by 0 cannot just go to infinity, because even though when you approach 1 divided by 0, like 1 divided by 0.1 is 10, 1 divided by 0.01 is 100, and as you get closer and closer to 0, you get bigger and bigger positive numbers. But that's only if you come from the positive side. If you come from the negative side, 1 divided by negative 0.1, negative 0.01, you just get bigger and bigger negative numbers. So in the middle, it's between 2 ways of getting to 0. One that just goes to positive infinity, and one that just goes to negative infinity. But what do we really mean by positive and negative infinity? They're not actually numbers. All positive infinity means is getting bigger and bigger positive numbers with no end, and all negative infinity means getting bigger negative numbers with no end. It's not really a number, it's just a concept and a way numbers can go. But then, what did I mean when I said 1 divided by 0 is infinity? I wasn't actually talking about infinity, like the concept. I was talking about it more in the form of a number. But let's not call it infinity or even unsigned, not positive nor negative infinity. Let's just call it anti-zero, because it is 1 divided by 0. And a property that it will have is that if you divide 1 by it, 1 divided by anti-zero will be 0, and 1 divided by 0 will be anti-zero. That kind of thing. And anti-zero multiplied by any number will just be anti-zero. Anti-zero minus or plus any finite number will just be anti-zero. Now, this sounds like I'm just making something up, but that's exactly what we did for the square root of -1. We just called it I, and it wasn't actually a random idea like saying that let's make a new number called triangle or whatever, because it actually fit really, really well into the system of mathematics, and it opened our mind and made it the picture more complete, and it's as if it wasn't invented, but really just invented with our intuition, and then really we discovered a lot more that was already there, and we only had to use our imagination. And this is what's happened here, and it doesn't seem to break anything really in maths. And if you see, anti-zero actually behaves a lot like 0, because anything multiplied by it will be it. So it destroys the information and is not really function, because different inputs will always have the same output, and just behaves a lot like 0. So anyway, I will truly see you next time on Science Spider. What do you think was falsely or something? Bye!